Okay, it's Bentley's mom again. We're going to continue on what the outlier is on the same problem. I'm on example 2. So what you have to do to technically find the outlier, rather than just looking at it going, oh, that number looks far away from the rest of the data, is you take the interquartile range, which we found was 15, and you do that by doing Q3 minus Q1, so we get 15. Then we're going to multiply that by 1.5. You always multiply it by 1.5 because that's the distance it has to be considered statistically an outlier. So 1.5 times 15 is 22.5. Now I'm going to call this the magic number. Okay? Once you get your magic number, this is how far it can deviate from, this is how far it can deviate from the data set. Okay? So what you do is you take the Q1, which is 48, and it can be 22.5 this way. If it's further than that, it's going to be an outlier. So you're going to take the Q1 and you're going to subtract the outlier, which is 22.5, okay, and you get 25.5. Okay, so is this lower than 25.5? Yes. So because 23 is lower than that, so anything that's here and below would be considered mathematically an outlier. You can have more than one outlier. So 23 is an outlier here for the lower one. Now we have to check our upper outlier. So we're going to take Q3, but instead of subtracting the magic number, we're going to add the magic number because it can be 22.5 spaces away from this one going to the right and 22.5 spaces going from this one to the left. So when we add those together, we get 85.5. Okay, is 72 bigger than 85.5? No, it's not far enough to be an outlier. So there's only one outlier in this data set, and it's 23. Okay, sometimes there's no outlier. Sometimes there can be more than one outlier, and sometimes there's just one. Okay, but technically, again, you have to find the magic number, again, which is you take whatever your interquartile range is, and you multiply it always by 1.5. Once you get that number, you subtract it from Q1, and you add it to Q3. And if these numbers on the end are above or below those numbers, then those are considered outliers. Okay? This is a very hard concept to understand exactly how to find statistically an outlier. So as long as if you can try to follow this, that's great. These ones you definitely, hopefully will pick up, but this is very difficult. But you should know the concept of an outlier, which is a piece of data that's nowhere near the rest of the data set. Because as long as you have that concept in mind, you'll get this definitely, next year you'll go over it and even the year after, okay? So that is the explanation. And then I will do, should I do a guided practice right now? Or should I wait and do that? You want me to do guided practice?
Just wait, yeah. Do it in the homework.
Okay. Well, I think guided practice is in the homework. Let me do one. I'll just go through the guided practice, and I'll do some homework problems after. Okay. So the guided practice, it gives you this data set. So I'm doing the guided practice. Okay, and this is number 1. Here's our data set. 7.5, 7.6, 7.7, 8.9, 9.0, 9.5, and 11.0. Okay? So it says A, find the range. So the range, okay, I put the data in order. Okay, so if you have to pull it off of a chart or table, make sure you list it in order first. Then we're going to do the biggest number, which is 11.0. We're going to subtract out the smallest number. Okay, and we get 3.5. This is our range. Okay, and then B, it says find the median and the first and third quartiles. So we're going to find the median Okay, so we're gonna take our numbers, 1, 2, 3, 1, 2, 3, and the median is this one right here. Okay, which is the middle. Okay, this cuts the data in half, 50% and 50% on each side. So our median is 8.9. Okay, then we're gonna find quartile 1, Q1, and we're gonna ignore this, and we're gonna find the median again here, which is right here, and that's Q1. So that's 7.6. And then Q3, okay, let's see, and then Q3, we're gonna do the same over here, and so Q3 is 9.5. Okay, so there's a range, median, Q1, and Q3. Then it says C, find the interquartile range. So the interquartile range is you take Q3, which is 9.5, and we're going to subtract out Q1, which is 7.6. Okay, and we get 1.9. Okay, and that's our interquartile range. And then D is, let's identify any outliers. This is the hard one. Because before this math, this looks like 6th grade math to me. So even though you're 5th graders, you're taking 6th grade math. Before that, you could kind of look at it and go, oh yeah, that piece of data is outlying way out there. I'm just going to write it as an outlier. That's just eyeballing it. But we're not going to do that anymore. We have to find out exactly if it's an outlier or not. So what you do is you take the interquartile range, and if you remember, to get the magic number, what do we multiply this by? Bentley, do you remember?
1.5.
1.5, good. Okay, and in this case, you get 2.85. This is called what I call the magic number. So you take quartile 1, which is 7.6, and we're going to subtract the magic number. Okay, and when you do that, you get 4.75. Okay, so let's look. Is there a number that's 4.75 or lower? No. Okay, so there's no lower outlier. Now for the upper outlier, we're going to take 9.5, which is Q3, and we're going to add the magic number, which is 2.85, and we get 12.35. Is there anything in the data set that's 12.35 or bigger? No, the biggest number is 11. There's no outlier here, and there's no outlier here. So what you would say if I said, is there an outlier? After you do all of this math, you're going to write no outlier. Can you see this, Bentley? Is it too loud?
It's just barely.
Okay, so you write no outlier or none.
Don't write any lower than that.
Yeah, and definitely don't write 0, because 0 is actually a number on the number line. So you need to write no outlier, okay, or something like that. Okay, and then, yeah, I think that's good. That's the guide to practice.